Hello, so I want to show you a graph from a paper that I absolutely love. And it's a graph not of the results, but it's a graph of the idea. And here it is. Okay, so you see here two things and we'll go over them. The first thing you see is you basically see a scale miles per hour, 0, 10, 20, 30, 40, 50, and so on. We all have seen those things before. Here, let's see it, miles per hour. But this scale actually has another scale, and this other scale is minutes per 10 miles. How many minutes does it take? How many minutes does it take to do 10 miles, right? So when you drive 100, it takes 6 minutes. When you drive 40, it takes 15 minutes. When you drive 10, it takes 60 minutes, right? How many minutes per 10 mile, right? When you drive 10 miles per hour, it takes you 60 minutes to do 10 miles. Okay. Now, the interesting thing about this is that when we think about miles per hour, the standard, we get to think about something linear. We say, oh, I'm driving 20 instead of 10, I'm driving 90 instead of 80, I'm driving 60 instead of 70. We have this temptation to say, I want to drive faster. Let's say we're driving a long way. I drove from New York back to North Carolina, long way to drive, and I'm driving basically on the speed limit. I said, what if I go 5 miles longer, faster? Right? It feels that as we go faster, we'll get there faster, which of course is true. But the amount seems kind of linear. Right? When you think about it, driving 50 versus 40 versus driving 60 versus 50, 70 versus 80, and so on. But this is not true. What this graph shows, if you drive 10 miles per hour, it will take you 60 minutes to drive 10 miles. If you go to 20, it's half the time. If you go to 30, it goes to a third, right? 60, 30, and if you go to 60, it's 10 minutes. So what you see here is in the beginning of the graph, as you drive faster at this level, it makes a real difference. If you drive at 20 instead of 10, that's a huge difference. You're making it in half the time. If you drive between 50 and 60, you're moving it from 12 minutes to 10. So basically, speed looks to us like it's linear, but when you think about minutes per 10 miles, which basically says, how long will this drive take me? We have huge gains when we increase our speed from very low to slightly lower, but when we drive already fast, between 60 and 70, not a big difference. So when I was driving, I was thinking, there's a temptation to drive faster. And the reality is that there's also temptation to risk things. It is dangerous to drive faster. And I think that if I had my dashboard showing me miles per 10 minutes instead of miles per hour, I would have realized that the difference between 60 and 70 is not that big, in fact. Right? Imagine that we didn't have this at all, and we just had the scale of minutes per 10 miles. I think we would have all been driving a little slower. Do I really care if it's going to be 10 minutes per 10 miles or 9? Is that such a big difference? In any case, it does add up when you drive from New York to North Carolina. But I think in regular trips, it's an example of a scale that would make us to think differently. And this is actually the point that this paper is trying to make, and the point I want to emphasize here. We don't observe reality. Reality is mediated to us. It's mediated by our brain, it's mediated by instruments. And when the instruments pick to depict one element, miles per hour, we get to think about it differently. And when the instruments depict something else, like minutes per 10 miles, we start to think about it differently. So maybe what we should do is we should think about all the ways that things are mediated to us and to say which mediation is not compatible with good decision making and which other mediations we should try and fix. And with that, I will leave you. Lots of work to do on that. I'm sure we can do much better, not just in speed, but in other elements as well. All the best.